Good evening, everybody. Welcome to Shop Talk, hosted by the Triangle Area SQL Server Users Group. So tonight we have with us our regular cast of fine fellows. First of all, we have Mala. How you doing, Mala?
Good evening, everyone. Doing well, thank you.
Excellent. And we also have Mike. How's it going, Mike?
Very well. Hi, Kevin, Mala. Hi, everybody. Doing well, thanks.
The first thing I wanted to call out is that the 8KB conference is open for registration. This will take place on July 28th. Registration, as you would expect, is free. 8kb.online. So go check that out. There are some very in-depth sessions. In fact, one of the sessions for this time around is Jeff Moden, who gave the talk for TriPass earlier in the year and was sufficiently brain melty that 8KB liked it. So you can go check that out a second time and try to pick up a little bit more this time around. Or go back and watch the video as well, so that's also an option.
Brain melty. Word of the day. Yeah.
It was definitely of the maximal cranial capacity type of talk. You are on mute, Mala.
No, Kevin, was it? I watched Jeff's talk and I didn't think it was way up there. I don't know. That's my opinion.
This one, I think the one, I'll have to double check, but I believe this is the one that was unique identifiers. Yep. Unique identifiers and fragmentation, and how historically we've had
fragmentation.
this.
Yeah.
Yeah.
Hmm.
So it was pretty internalsy. Next, Mike's got some news.
Well, my news is I wanted to thank everybody. In part, I had gotten a promotion that I wanted at Duke, so I'm very grateful.
Congrats.
Thank you very much. So,
yeah, definitely. So, chat, this is all because of you. You've brought
Right.
Mike over the crest, and he was able to get that promotion. And so I think that means that he's going to mail each one of you a check. So just sit by the mailbox and wait for that check. We'll get it.
I love that.
we're not in Anders, though. I mean, everybody but Anders. Sorry.
That's fair. That's fair.
No, thanks very much. Sincerely, over the last, I started in 2018. I've probably been to the 35 or 40 meetings. Obviously not all of them, and just learned a ton, and also gotten to learn some of the other resources, SQL Shack and Grant Fitchie and Kellenberger and the Kimball normalization forums, et cetera. So I think that it's just really helped me tremendously. So it's a shout out to the expertise in this group, the professionalism, the exposure to different things. And my role will be similar. I'm going to be doing data warehouse development for a data mart for a researcher. I'm just going to be working full time for a PhD in biostatistics. He's a nationally known biostatistician. So it'll be an opportunity for me to learn and do more SQL Server, and do some business analyst work too, so like helping data scientists connect the database in Linux, helping them do it in different distros and documenting all that. That's one of my first projects, right? So all that stuff matters. So anyway, thank you. I appreciate it.
Great. Yeah, glad to hear this. And I would say this is part of the power of community. This is showing up, putting in that effort, bettering yourself, and getting some of the positive results from that. So glad to hear that, Mike. So we have two topics of interest tonight, unless chat is able to derail us like they're so good at. The first topic comes from you, Mala. So how about you want to set that one up?
Sure. So the topic I asked Kevin that we discuss is on linked servers. So everybody, those of us who've been DBAs know that linked servers are a pain to manage, and we'd like to have our developers use them as less as possible. So I'm working on a project at work where I am researching. I wouldn't say we use a lot of link servers, but we do use them considerably high level. And some of the usage that I have seen has been mostly around querying, some updates to remote data, some reporting kind of stuff, which is the same thing as querying, but that kind of stuff, and some ETL DBA related work, which to me can be done with PowerShell easily. In fact, that should be the easiest to get rid of. But the other two, I am not sure if replacing them with the alternates that are commonly suggested, which is mainly using the open query set and that kind of directly in the query. I'm not sure if that is worth the trade-off of getting rid of link servers. I'm not saying yes or no. I'm just not sure.
Yeah, so this is a good topic for getting into discussion, and I'm going to try to take it from a fairly generic standpoint, not necessarily about any particular company's needs. Mala mentioned that was an employer-related request, but I'm going to try to keep it generic so that the most people can benefit from it. So there are a few different alternatives to linked servers, and as much as I dislike linked servers, they do have their value. So I do want to start from the standpoint that linked servers are not entirely evil, they're not baneful, they're not improper solution to every problem. There are cases in which linked servers are a valid and successful answer to a specific question. And that specific question is usually about, I want to retrieve data from some remote server. Occasionally, I want to insert data into or update data from some remote server. So I don't have all of my data local to a SQL Server instance, and I have some business problem that requires working with multiple servers. Anders calls them worse than cursors. I'm willing to agree with you on that. And I know the spot of love in your heart that you have for cursors, so I think that there's a ground where we can both be right. So as far as alternatives go, Mala talked about Open Row Set. Open Row Set is the first alternative. This is usually going to be useful for ad hoc queries. You have to set up the driver information. Basically, a linked server, not exactly the same thing as this, but you can think of it as kind of, I have an open row set where if I have to run this over and over and over, why don't I just make something permanent that allows me to just connect to that machine over there using these credentials, using this driver, which is what you're doing with Open Row Set, but making it a little bit more of a permanent thing. So Open Row Set can be really good for simple queries, occasional queries. It's used pretty frequently in things like serverless, so Azure Synapse Analytics serverless SQL pools, or even Azure SQL Database serverless would use Open Row Set quite a bit to read data from some file. Another alternative is to use Polybase if you're in SQL Server 2019. Polybase will allow you to connect one SQL Server instance to another SQL Server instance as of 2019. If you're on 2016 or 2017, not going to work.
That's interesting, Kevin. Okay.
Now, Polybase and linked servers are significantly different in the sense that Polybase is really intended for single database, usually single table, exposing a single table. You create each external table separately, which means that if I have 3 of them to do, that makes a lot of sense. If I have 3,000 tables, this makes a lot less sense. Also, if I have hundreds of databases and I want to arbitrarily select a database and a table, Polybase is not going to be your best answer for this. It is instead more for very specific problems of, for example, ELT. I need to extract data from this remote SQL Server instance, make it available, pull it over to my SQL Server instance, and store it perhaps in a warehouse. So this is what Polybase is really good at. It's not good at arbitrary querying. It's almost the opposite of OpenRowSet, where OpenRowSet completely ad hoc. Polybase is almost completely structured. Linked servers are somewhere in between, but they're much closer to ad hoc.
Yeah,
Because
that I agree. Yeah.
yeah, I just set up the server, and as long as I have, whatever permissions I'm using, I'm going to have whatever access I can get across there. If you're using newer versions of SQL Server, linked servers don't hurt as much as before. I remember back in the 2008 days, for example, that if you were not using a sysadmin account, then the remote queries could not use statistics, and performance would suffer as a result.
Yeah, I do remember that too. Yeah.
Yeah, but that has changed. So it's a little bit better in that regard. Now, this is where I probably ask, well, why is the data over in a remote server? And if the answer is that's just the way it is, and we need to get that data over here, then now we can talk about some data migration using ETL tools. That could be something built in like SQL Server Integration Services. It could be a purchased platform, Informatica. It could be building your own .NET code. Solomon here is talking about SQL CLR for sending data and using bulk copy to migrate data along. That's another option. Building your own application code to move data from one place to another. Really, really good if I need to do it one time, or if I can do it on a consistent schedule and I know which rows I need to move over. If it's the entire table, if it's this specific subset, if getting that information is fairly easy and migrating over, then integration services, Informatica, Azure Data Factory, if you're in Azure, building your own custom application, building your own .NET app or Java app or Python script or whatever. PowerShell, as Mala mentioned. All of those are viable options. And as your situation becomes more complex, then I lean much more toward the custom code solution. Meaning, if I have, for example, hundreds of tables, hundreds of databases on instances, and I need to arbitrarily pull data from collections of those, then probably going to benefit from app code much more than trying to build out linked servers and query data that way, or build out all the external tables in Polybase, or even using integration services. Because even if you're using integration services and building a package using BIML, or you're building dynamic integration services packages, they're never that dynamic. So as your situation becomes more complicated, as the underlying servers, number of instances, number of databases, number of tables, as that increases, it makes the likelihood of app code being the best answer significantly higher.
That
so
makes
Mike, you're
total
asking,
sense, David.
You asked the question, Mike, OpenXML, is that similar to OpenRowSet? I believe the answer is no, but I'd have to double check because XML has a good practice of blanking. Like I blank out whenever I see the term XML as a defense mechanism. So I don't remember the last time I've actually used anything along the lines of OpenXML.
So if you're saying When you say app code, do you mean like, okay, so SQL Server is kind of integrated with R and Python, that you would write Python to go get data from another database, or you would just build a .NET app? Is that what you mean?
That's yet another option, machine learning services. I was thinking about just having an application server, an app server that knows to connect to the source, do whatever work it needs to do, put it into the destination. So even a level higher than what you're mentioning. And after I had a quick chance to hit OpenXML in Microsoft Docs, no, very different. OpenXML provides a row set. Oh, you can do OpenXML over Open Row Set. So it's a little different because OpenXML is all about, looks like it's parsing an XML document and building out a data set as a result of it. So if you're interested in OpenXML, there's nothing I can do for you, but I did put a link in chat.
I was just about to say, the joke's coming in. If you're interested in that, I'm sorry.
Yeah, I projected that one. So ML services, machine learning services, is another possible option here because, like Mike mentioned, with R, with Python, you have the possibility of opening up an ODBC connection to a remote server and doing whatever work. This is something I might do if I have somewhat complicated requirements, but I can't get access to an application server. So I think we've all been in companies where, because of restrictions between teams or budgeting restrictions or rules that are in place, it's so much easier just to do it in SQL Server than try to get a remote server. And if you're in a company like that where getting an app server is going to take 6 months, sorry. A, that's crazy. B, you could potentially use something like machine learning services as a very, very expensive app server, in the sense that you're paying a lot of money for those SQL Server CPUs, and ideally you want them operating on their highest priority task, which is usually working with data. But if you have more red tape than database queries, then it'd be possible to use ML services, pull some of that information. Or as an alternative, if you need that data because it's part of a data science task. So I'm going to do some querying of this remote data. I'm going to develop a model and, say, implement that model in my SQL Server instance. Now, machine learning services does make a lot more sense for this particular task. That said, what makes even more sense potentially could be to use a separate app server to do that data migration and initial data cleansing operations. So Solomon mentions that you can use OpenXML in place of select star from xml_var.nodes/xpath/, if I remember correctly. You probably do remember. Solomon knows a lot more about XML than I will ever care to learn.
He might be, on the same category as my old friend Jacob Sebastian from India, who was another XML geek. He loved XML. Yeah, for whatever reason.
There's
it's
all
on
types.
Kevin's not-do list at the very end, way past TypeScript.
XPath has been way down on the list, yes. It's something that I know just enough about to solve specific problems with extended events. I know just a little bit more about it than I'll be willing to admit, but not enough that I would want to do anything serious with XML data. Most of the time it's take this data, shred it, turn it into a table, and now I can make use of it. Whereas I know that you can get much more sophisticated in querying XML data. It's just something that I've not had the inclination to go down that path. There is another option as well. I'm going to call this the fifth option, it looks like. Technically sixth, if you include keep the linked services. Data virtualization. There are third-party solutions that will work to virtualize your data. So if I have data in a SQL Server instance here, I have other data in a SQL Server instance here, I may have other data as well in Oracle or Teradata or whatever. Then a data virtualization layer is a product that is aware of each one of these instances and will allow you to query across them to connect data from those instances seamlessly, which is not totally a marketing lie, but it is mostly a marketing lie, because seamlessly is also a synonym for very slowly when it comes to these products.
I love that. Well said, Kevin.
And that's one of the major issues that you'll run into, where you run into it with Polybase as well. You're not going to be able to do multi-layer filtering. So if your operation is select star from here, bring the two together, union them together, data virtualization will work great. But if it's a even fairly complicated query where there's a filter in here which will result in a lot fewer rows here, most of those tools... Oh, we're going to have mic number 2 in here. Have some mic problems, but most of those tools are not going to be sophisticated enough to really understand that if I pass down the results from here over to here, I won't get 5 million rows, I'll get 10 rows. And Polybase is a great example of that, where if I have even a local query, if I filter this down, like if I use this first and I send that data over, I'll get a much better result. Unfortunately, it doesn't work that way. Linked servers supposedly can do that. They can project data over either way. So you could take the results from your local instance, the local table, move them over to the remote table, and have the work be done over there if the local table has just a few rows and the remote table has a large number. Every once in a while, you might find a query that does this, but I think that doesn't happen very frequently. So Solomon says, I do like XML for certain things, more than JSON actually, and I realize I may be one of the few. Yeah, there are cases where XML can be useful, especially if you have something like the documentation of what the schema looks like, that XSD, where if you are one of those companies that took the time to build out a proper XSD, you can do a lot of great things with that. And you can build applications knowing that here is the defined schema. Here are all the possible attributes, their values, even the specific elements that are allowed within here. And if you were one of those who did it, then you could take big advantage of this. Most companies, though, didn't. And as a result, the XML is really just as arbitrary as what you'll find with JSON. As far as number of bytes go, I believe JSON is a bit more compact than XML, especially if you have much longer XML attribute names. If you need an XSD, you might as well put it in a relational database, says Anders. Probably. You can get into questions of... What's that, Mala?
I said I tend to agree with what he's saying there.
On the whole, I would think so. But remember that XML was originally intended for intercorporate data exchange.
Mm,
and where I can't give you access to my database. So I can give you an extract of this data.
mm-hmm.
When your alternatives for this are flat files, which have their own problems, and monstrous things like if you're in the healthcare world, 835s, 837s, just my throwing out some numbers should cause you to have a heart attack. Basically, those data exchanges that were developed in the mainframe days where the world was quite different, and trying to build out a solution that handles those types of medical interchange records like 835s or 837s, a little bit weird in a modern language because it's not comma delimited, it's not character delimited, it's not even fixed width either, because it'll be in this section, look for this character combination followed by this thing, and this thing should be a code for this, and it should be this many characters long unless there's this other value down here, in which case it should be this many characters long, and it just goes on. There's a whole processing language to it, which I'm hopefully making it sound very painful, because it is very painful. There are companies that make a good amount of money just in having these sorts of readers and writers of those medical forms. There wasn't a single XML that didn't need an XSD, many required multiple, in their headers because XML has no global environment for context of its vocabulary. Says Mike.
Interesting.
So, I agree if you're trying to do it correctly. In a lot of cases, what people did in practice was, here's an XML file, intuit from the information in that file what the schema looks like. And like I said, I agree with you, that's technically incorrect. That is not the right way to do it, but it was the easy way out. And there are enough tools that allow you to take that easy way out until they added a new attribute, in which case now your code is broken. And that's why, as Mike points out here, XML required verification and must be coded correctly. So yeah, if you were following all of those rules, then you get these additional benefits. And that's where the schema definition comes in. That's where the rules come into play, and you can build rules engines to ensure that this document I am sending you is a valid document and follows all of these specific rules. But in practice, a lot of people avoided that. A lot of people skipped it. At the large corporate level, I think you probably got a bit more adherence to those rules, to those specifications. All of the XML-based specs I knew required XML to be followed correctly. My response to you is XHTML. All right, so we have a big pain. Yeah, XHTML is an enormous pain. We have HTML. We want to add in XML. HTML was very lax in its rules, where it didn't necessarily need closing tags or that you follow the structures that, what if I want a span and a paragraphs inside my spans? Who cares? And then browsers supported it, and so I wrote my code so that I could get Netscape 3 to look right. And then XHTML comes in and says, we're going to do this a structured way, and then everybody laughed. That was your moment from the 90s. And we never recovered. So our next question, Mike being frozen in a very stern face, came from Bookmaster and script from IBM, something called ISIL. There's a joke in there that is not appropriate for shop talk. Yeah, so Mike C, you're currently frozen on here at least. I had let you in, but um, looks like maybe I'll try to boot you and we'll see if you can come in again. There we go. You should be able to just refresh your browser tab, and I'll bring you back in. So our next question came in from George Walke, who hit me up, asked a question. What's your preferred platform for doing ML experiments on large data? Databricks, Spark ML, Azure Synapse Analytics, Azure Machine Learning, on premises, something else. And so I decided I'm going to give a response, and the response was long enough that I thought, well, shoot, this actually makes for a pretty good shop talk question, I think. So as I'm doing this, chat, if you have thoughts on any of these technologies, go ahead, put them in. But I'm going to mention that my team generally uses a lot of on-premises tools, and part of that is simply that's where we're at. That's where we have our data. That's where we're able to operate. We've used SQL Server machine learning services quite a bit. I would register that we probably have one of the largest machine learning services uses in the world in terms of number of products, amount of data, amount of processing, and have broken it several times as a result. So that's kind of cool. So Anders, the question was, what would your preferred platform be for doing machine learning experiments on large data sets? And I believe that your answer will be none. Nothing. But we'll see. So on premises, definitely a solid answer. Like I mentioned, machine learning services is a good choice for specific use cases where, for example, your data lives in SQL Server, where you want your results in SQL Server. If you're using R and Python and don't necessarily want to move the data out to remote app servers. If you have batch operations where you're doing a lot of predictions at once versus the one at a time API style, where I have a single record that I want to send over, get a prediction back. So if you want that quick response, if you're using the predict operator in SQL Server, then it will be okay. And welcome back, Mike. So if you're using the predict operator in SQL Server, then you can get really fast results. That's native scoring. However, native scoring SQL Server on premises, SQL Server 2019, is limited to a small number of models that are relatively simple models. Most of the time, you're not going to be able to get anything interesting out of native scoring. And by simple models, I mean logistic regression, linear regression, decision tree, boosted decision tree, gradient boosting. Admittedly, that's a pretty good model. A random forest, and I believe there's one other model or one other algorithm that is supported, but it's somewhere between 5 and 6 algorithms supported. Nothing involving neural networks, nothing involving anything more complicated than a decision tree or a random forest. So most of the more interesting models nowadays are not going to work with native scoring in 2019. If you're using something like Azure SQL Edge, where you get native scoring on Onyx models, now I can have a neural network generate predictions natively. That, if you bring it into on-premises, opens up a lot more in the way of use cases for SQL Server machine learning services. So if I am in the market for sub-second response times, then we're probably going to have to build our own API. Build your own API. Typically, we've been doing a lot with both R and Python, setting up application servers. In Python, especially hosting something like Flask, front-ending with Unicorn. With R, generally it'll be hosting in Shiny, or simply having the R service and front-ending it with Nginx. We'll actually front-end both of those with Nginx to act as that reverse proxy and hit multiple servers as load requires. As far as on-prem goes, this is pretty easy if you're on a tight budget because you don't need much money. You've already paid for SQL Server, so you have machine learning services. If you're able to use it, no extra cost there. Or if you want to spin up an app server, for most companies, that's not a huge expense. Several gigs of RAM, some version of an operating system. I mean, usually in this space, Linux is the normal operating system, so you're not even paying a bunch of money there. And as a result, if you have a tight budget, on-prem is probably your best answer. There are also a lot of tools available. If you have good knowledge in that machine learning space, you can do pretty much anything that you want, even with large data sets. You may need more resources, you may need a fair amount of RAM. You can get a lot done here. On the downside, you're going to need more expertise because you're doing it all yourself, basically. So that's something that you'd want to keep in mind if you were looking on premises for machine learning, especially off of large data sets. Small data sets, you can run those on a laptop anywhere. Anybody can do work off of a small data set. It's when you're talking about larger and larger data sets where the extra work done in a pre-processing makes a difference, where the extra work done in model preparation makes a difference, and where a model can quickly go from megabytes to gigabytes to terabytes because I have extra features that need to be encoded. As far as Databricks goes, I like a lot of what they do. I am, however, not a big fan of Spark ML, of the machine learning library in Spark. It is incomplete, and the capabilities tend to lag behind a lot of other packages. I remember, admittedly, this is from a couple of years ago, so I don't know if it's been fixed or not, but there were bugs in things like linear regression in Spark ML, where you could feed in data, expect certain results, not get exactly those results, even though everything else would give you the correct answer. It was a little strange the way that it worked. Not intuitive if you're used to working with things like scikit-learn, or if you're in the tidyverse in R. And although you get the benefit of distributed operations, the distributed operations don't necessarily make things faster. They can make things faster if you have a lot of work that needs to be done in parallel, but not necessarily when it comes to all data science tasks. So it's going to depend again on how well you can pre-process your data and can you get roughly independent information and independent operations. To the extent that you can, Spark becomes a more viable choice. If you're on Databricks and you're using scikit-learn, if you're not using Spark ML or one of the libraries that's specifically dedicated to distributed machine learning, you're just using your driver node. You're not even using the workers, the compute nodes. And in that case, you're paying extra money for nothing. Might as well just spin up a EC2 or an Azure VM and put that much RAM on there and install what you need and do it that way. If you're using something like Azure ML or AWS SageMaker, those can be very good options. They have a couple of, I'll say, levels, where one level is I'm just an app developer. I just need to get a model created because that's my task this sprint. I don't want to dive into a lot of the details. I don't want to do it wrong. I want to do something reasonable, but I just don't have the time, inclination, or effort to get that PhD. So something like Azure Machine Learning's AutoML, or some of the similar automated machine learning in SageMaker, or third-party products that do automated machine learning, those can be good options. I did find that for Azure, AutoML does not work well on really large data sets. That as the data set gets larger, this thing falls apart fast. If you have a small to moderate data set, AutoML can work really well. If you use a custom library that does automated machine learning, that can work, that can scale out a bit better. But I would be concerned about using a large data set on an automated machine learning tool simply because of the expected way that it works. I mean, in a lot of cases, what you're doing is you're trading your expertise for brute force actions or heuristics followed by the product. Meaning, I have just enough information to tell you that this is a regression problem, and therefore, we're going to let it try a whole bunch of different regression algorithms. And that can slow things down quite a bit. Especially if you know that if you are more of a professional, you realize this type of regression isn't going to work. Linear regression won't work here because the variables are not linearly related. Or this other type of regression won't work because the characteristics of the data set indicate that this is unlikely to be a reasonable answer. If you have that extra information, well, the automated machine learning will take more time, will take more effort to get you to the same place. If you are, however, using a data set that's reasonably sized for Azure ML or for AWS SageMaker, they're going to be pretty solid. They will limit you in the algorithms you can choose, but in both cases, you can drop down into code and bring in something like scikit-learn. And now you get access to a lot more in the way of libraries and algorithms. As far as Azure Synapse Analytics goes, here's where I take a drink, because there are machine learning capabilities in Azure Synapse Analytics. You can do operations with Spark. So again, you're back to Spark machine learning, Spark ML. But not as fast as on Databricks. So not great. If you're using Spark for data processing, that's a bit of a different story. Spark is really useful for that. It's less useful for distributed machine learning tasks, where it's not going to be quite as useful. So you're working with Azure Synapse Analytics, and you have that issue, that same issue with Spark ML. Not a fantastic library. There are some limitations to it. The other thing is that there are two different product teams pushing two different products that have overlapping but not the same capabilities. So Azure Synapse Analytics will say, use machine learning in our product. Azure ML's team will say, use Azure Machine Learning to build out the models, and then it's okay to consume it from Azure Synapse Analytics, but don't use Azure Synapse Analytics to build that machine learning model. And there's a internal debate within the company. And when you have these two product teams that are giving advice that's contradictory, as an end user, you have the question of, well, what should I do here? Last year, it seemed like the answer was use Azure Machine Learning. Go use that, go set it up, do all of your machine learning over there, bring the data back, make it available to Azure Synapse Analytics. That message may be changing. And I'm not going to tell you either way. Yeah, definitely the message is this, because I think right now it's a little bit confused. So keeping that in mind, Azure Synapse Analytics can be useful. You can do machine learning in there. Whether you should do it in there is a matter of debate, and it's going to depend on which person you ask, which product team you ask. And there could be some compromise where you use Azure ML as a linked service within Azure Synapse Analytics. And in that case, oh, well, I'm just tying to this remote system and doing my machine learning work on the Azure ML compute instance while working within the Azure Synapse Analytics workspace. And that may be where we land. I'm honestly not sure. So those are the key options that I have in mind when you're dealing with a fairly large data set. You know, my bias here, my experience here is mostly on premises. My biases will tend to be on-prem more than in the cloud. And I think that you can get more bang for the buck that way. But if you just need to spin up something real fast and perform an operation, what is considered a large data set, Anders asks. That is a great question. It
depends.
I was gonna say it depends, but I wanted to change it and change it to something else, but no, it really does depend. And one of the major things that it depends on is what is the type of operation you're doing. So if I'm doing, for example, natural language processing, a book may be a really large data set. It's only a few hundred pages. It may only be a couple megabytes, but that can actually be a fairly large data set if you're thinking about the possible number of words in that book. So if you have an author with an extended vocabulary, you know, you might have 8,000 to 10,000 separate words in there, and your matrix now has 8 to 10,000 elements. So that means you're going to require quite a bit of memory to basically process all of those different words. Now, that by itself might not be a large enough set. If you're talking about hundreds of books, thousands of books, you know, now we're talking pretty significant amounts of data. And if we start large data with it's more information than a researcher would typically be able to operate on their laptop, I think that's a reasonable starting point. Or that an operator, a data scientist, or so on may be able to perform on a normal sized virtual machine or server that they have access to. And I think that hits on some of what you're talking about, Anders, where, look, we have some significant difference of opinion on what large is for a place. And my laptop has more performance than my servers did 10 years ago. Hey, that's true. But, you know, that does change. So now, if your laptop can do this work, it's probably not a large data set, if that's the type of work that you're doing. And yeah, my desktop here is a lot more powerful than most of the servers I deal with. So that scope grows to where I may not be able to talk about this in terms of a few hundred gigabytes. You know, we may have to talk about terabytes or hundreds of terabytes before it really makes sense on this server for this company. But I think that the size, a shadowy GPU connection, I'm not going to say I don't have a connection that way, but I would say that if I did, I'd probably have more than one GPU. 5 million rows, tables of 25 columns. Maybe it needs to be in processing time, not size. Well, we normally talk about it in terms of size, especially in memory utilization. So it's not necessarily about size on disk. It's about how much memory does it take. Because, like I mentioned, that book, if you have a book that has 5,000 unique words, the text.txt version of it that you might pull from the Gutenberg project may only be a few hundred kilobytes, but it could take up dozens of megabytes of memory as you process this information. As you get the sparse matrix of all of the possible words filled out, that may take a lot more space than what it would on as a text file. So it's processing in memory or effort done when working in memory. That, I think, is the differentiator between large and not so large. So, Mike, you set up Aquadata Studio so that you can configure how much memory you can use to handle work. How does that work for you?
Works very well. So we've experimented a lot. So sometimes we do a lot of large files, and this isn't very sophisticated, but we might have 10 million records, and just getting researchers to be able to use it or to have like special tools to use it if it's not in a database. So we've been doing a lot of different things. So so SQL Developer is terrible at that. I mean, it's terrible. So Aquadata Studio can export like 5,000 rows a second if it's to disk. But in Python, one of our colleagues figured out how to do it. And then I think you can do probably, I don't know if you could do it in SQL command line. There's SQL CMD and Oracle, but there's tools like that. But Aquadata Studio was one way that we tried to do it that was much faster, because you can configure how much memory the program uses. Whereas in SQL Developer, it's kind of a nightmare. And then I'm experimenting with Aquadata Studio, but I don't know enough yet.
Yeah, that's not something. I think I've looked at Aquadata Studio before, but I don't think I've ever used it.
I love it, but it is expensive, so we're moving away from it. And they're starting to use DB Beaver.
Ah, yeah. dbeaver, yeah. So that, by the way, for folks who don't know, that is a multi-platform open source data client, SQL client. Works really well with MySQL, Postgres. Will connect to SQL Server and Oracle, and pretty much if it has an ODBC connector, dbeaver can connect to it. It's not as sophisticated or as nice as some of the higher end tools like Management Studio and SQL Server or Toad and Oracle, but it is free, so the price is right. Azure Data Studio is kind of in that similar space where they're aiming for the multi-platform, multi-product approach. Although as of today, the multi-platform is there, but the multi-product is mostly SQL Server and Postgres. You're not going to get
SQLite, yeah.
Yeah. So you're not going to get a bunch of other platforms, you know, like MySQL, Oracle, and so on, out of Azure Data Studio today. So that was, I think.
Oh, sorry to interrupt, but can you do could SSMS do that?
No, Management Studio is just for SQL Server.
Yeah, that's what I thought. Okay. Thanks.
Now, tying our two topics together, if I do have a Postgres instance or an Oracle instance or Anders' Access 2, maybe not Access 2.0, but if I do have that, I can use a linked server to connect my SQL Server instance to that remote instance and query it as though it were kind of like a SQL Server. So that way I might have my Postgres driver. I could connect to a remote Postgres instance, use the credentials passed that way, and query data from there in Management Studio. Similarly, I can set up a external table using Polybase. That'll connect to Postgres, that'll connect to MySQL, to Oracle, to DB2. And Raymond has a link to dbeaver, so that is in the notes here. And check that link out. It is, like I said, it's a free open source product. Works pretty well for what it is.
What, the Beaver thing came in?
Yes.
Interesting.
Yeah,
I mean, there is a paid version that has extra features.
Okay. Yeah, I wouldn't replace SQL Server Management Studio or Azure Data Studio with it, but if I'm using, if I work at a company where I'm regularly on 5-6 different types of database, then this tool I think is a pretty solid one, because at least it provides a consistent interaction with each one of them.
So it's a competitor to Azure Data Studio, Kevin?
Sort of, yes, except that no, just for a quick tool when jumping around on Mac and or Windows. So I think, I'm not sure if Raymond disagreed with me or not. So let me clarify that, yeah, I wouldn't necessarily use it as a first product, because it's adequate, but it's not great. However,
now the IntelliSense, another great thing. Yeah, it's not going to have it. Okay.
Yeah. However, its benefit is in its versatility, so that I can access a lot of different types of database using the same product. So I can be familiar with the product even if I'm not necessarily as familiar with the remote system. But as you spend more time on the one product, then on the one remote system, then you'll probably want a product that is specially designed for it.
And that was a really good point that he brought up, because like I have a programmer friend who does a lot of Python and JavaScript, and he does database management. He uses Aqua Data Studio and dbeaver to poke around, but he's writing code all day. He's not really doing SQL.
Mm-hmm.
He uses those tools to look at everything.
Yeah, it relies on various ODBC tooling. Yeah, so you're going to set up those the drivers locally and be able to connect to a remote instance that way. So we have hit just about the top of the hour. Those were our two topics. Surprisingly, there was relatively little derailment today. Or I allowed just enough derailment to get us to our hour. Chat, you did perfectly. You derailed just the exact correct amount. And you got Mike a promotion. So you have done a fantastic job this week, chat. Great. We expect big things from you in 2 weeks. So tomorrow,
Thank you.
Tomorrow we have Joshua Higginbotham talking to us about ETL with Python. And then we are going to pack it in until July when we start all over again. So check it out, meetup.com/trypass for the meeting tomorrow. And then we'll pick it up again in July with a few more meetings. So until then, everybody, have a wonderful evening.
Thank you. Bye.
Thanks, everybody.